All right, so I'm going to show you guys how to do the first couple of problems on the Oompa Loompa worksheet. So you guys were assigned, I think I said 6 through 12, but you guys had already done 6. So we're going to start with 7 today. You basically want to be starting where we're talking about hair. So Oompa Loompas have red, purple, or blue hair. And you want to make a key of showing this. Now you don't have to do it the same way I do, but you just have to be consistent. So I'm going to use H for hair, and I'm going to say that HH is red, H prime H is purple. So remember, you always want your heterozygote to be one of each. And so whatever the middle thing is, like if you mix red and blue, you get purple. Whatever the middle condition is, needs to be the heterozygous one. And then H prime is blue. So this is just, problem 7 is just asking to make a key. So make a key so I can see what it is that you're going to do for each of your problems, and then you can move on to 8. So for 8, Orville Oompa has purple hair, so that should tell you his genotype. He has to be a heterozygote. And then he's married to Opal Oompa, who brags that she has the bluest hair in the valley. So she has to be H prime, according to my key. Okay? Now, the question is, how many of Opal's children will be able to brag about their blue hair? So let's make a cross. Now, you only have to do as many boxes as are necessary. So Orville, he can donate either H prime or H. He can donate the blue trait or the red trait. But Opal can only donate H prime. So I'm just going to make a 2 box. Ooh, that is not what I meant to write. I'm just going to make a 2 box Punnett square here to save myself some time. And you guys are welcome to do this also. So H prime. So what they're going to get is half of the children having blue hair and half of the children having purple hair. So to answer the question, how many of Opal's children will be able to brag? We don't know how many children they have, so it's fine to just leave this answer as 50% or half blue. All right, I am going to show you a few of the other problems from the Genetics Problems 2 worksheet. So go ahead and pause this and just turn there. So this is on Genetics Problem Worksheet 2. I am going to do problem number 5, and then for the sex-linked traits to show you guys how this works. So in fruit flies, red eye color is dominant over white eye color, and the trait is sex-linked. So that's going to tell us that we need to use chromosomes XX for females and XY for males. So what genotypes and phenotypes will result from a cross between a red-eyed male and a heterozygous red-eyed female? So first, let's take our red-eyed male. Now, if you want to help keep track of this, what I'll do for my key here is I will do XR because it's dominant. I'll do XR to keep track of red, and then X little r to keep track of white. Okay, and so that'll remind me that this is dominant to this, but that it's sex-linked. So in a red-eyed male, he only has one X. So because he's red, we know that this is XRY. And then the female has XX, but she's heterozygous. So one big R, one little r. Now we're just going to do this cross like we would normally do. We need all 4 boxes of our Punnett square here. The male goes here. Female is going to go here, although it doesn't really matter which side you put them on. Okay, so now our cross is finished. And we can write out what we would have. So we get 1/2. Look at our females. They all have at least one big R. So we get 1/2 red eyes female 1/4 red eye males and 1/4 white eye males. All right. If you have questions about these problems, just save them and hop on Zoom, but hopefully this will help you get started.